Hey Algebros, I'm just going to continue to make some videos to help you guys out. So today we're doing 9-2 part 1, only part 1. So you'll notice when you do the homework tonight, it might give you some other equations, but I only want you to evaluate. So you're just looking at the final solution, and I'll talk about that in class as well. So don't worry about the other part of the equation that's on there. We're going to be doing that tomorrow. So today we're really defining what's the difference between a series and a sequence. A series and a sequence. And don't forget, you can pause the video at any time to write things down. A sequence that we've been doing, like this one, is 1, 2, 3, 4, when I know I'm adding 1 each time. But a series is when I am accumulating a sequence, like 1 plus 2 plus 3 plus 4. Let's do another example. If I add 2 instead, then I'd be counting by 2s, which would be 2, 4, 6, 8. But if I do that with a series, that means I'd be adding 2 plus 4 plus 6 plus 8, a much larger number. What if I do fractions? Remember, this was kind of like one of our homework problems, but if I have 1/2 plus 1/3, 1/4, 1/5, I'm just adding 1 to the denominator, right? But if I do this with fractions in a series, then I'm adding the fractions 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6. And we're talking about summations today, so I just want to give you an idea of kind of what a summation looks like. So if I take the second series, which I've done a little purple star by, and I do a partial sum of this, then I would look at it. The first term in here is at the S1. The sum of the first term is 2. Then the sum of the second term would be 2 plus 4. The sum of the third term would be 2 plus 4 plus 6. And the sum of the fourth term and so forth would be all of them. Okay? In both series and sequences, we always have rules, right? Let's go back to our sequences. The first one I know is just the step value is the total value of the term. So first step is 1. Second step is worth 2. Third step is 3, and the value is 3, and so forth. On our second, I am doubling it, right? So whatever the step I'm on, I'm multiplying by 2. First step, 1 times 2 is 2. Second step, 2 times 2 is 4. Third step, 3 times 2 is 6, and so forth. And on our last step, this was like one of our homework problems, I can see that I'm just adding 1 to the denominator. Just adding 1 to the denominator, right? Okay, when I talk about summation notation and series, I want to remember that the n can be replaced with this letter called k for a lot of reasons, but we just want to remember that it can be replaced by the letter k. So that's what I'm showing you right now. So make sure you make note of that. Now let's look at how we would do this summation notation. We use a Greek capital letter for sigma, which is this kind of funky E, and then each part of the letter has a place that represents some part of the summation. The center of it in red is the rule for the sequence. So we would put our rules that we've been learning how to do there. Our first value of k is where do we start? What step do we start on? And our last value of k is what's the last step that we want to end on. Let's look at an example. If I give you the rule of k plus 1 and ask you to find the sum of the first 4 rules combined, we actually mean the first 4 terms. So I would put that my rule is k plus 1. My starting is the first step, and my ending is the last step I want to end on is 4. So I know I'm repeating and adding together this rule, k plus 1, 4 times, right? And then the k value just is, my first value will be 1 because I'm starting there. And then my last value will be 4. So that's why it's 1 plus 1 plus 2 plus 1 plus 3 plus 1 plus 4 plus 1. All of the red are all of the steps I do. The first step, second step, third, and fourth. And then the others, I'm always adding 1. And when I do the math, I get 14. Let's try another one. If I give you the rule of 2k plus 1 and ask you to find the first 5 terms, I know how to put the rule where it's supposed to be, and I'm going to end on the 5th term, and I'm going to start with the first. So I know I'm going to be repeating this 2k plus 1 5 times, right? But the k value is what changes according to the step. So I'm starting on step 1, so I want to change that to step 1, and then change all of them to be the continual step. Step 1 plus step 2 plus step 3 plus step 4 plus step 5. And then I do the math. All right, let's try one more. If I give you that the rule is k plus 2, but this time I ask you to find the sum of the terms 6 through 10, I'm starting, my first value of k is actually 6. And I'm ending on 10. So if I count, how many times am I going to be repeating this? Well, 6, 7, 8, 9, 10 is actually 5 times I'm going to be repeating the formula. And then I put in my first value. Instead of being 1, my first step is actually starting at 6. So I go 6, 7, 8, 9, and 10. And then I need to do the math. Once I do the math, then I know how to do it. This is all we're doing for part 1, and we'll get into part 2 tomorrow. So you'll notice when you go to check your answers in the textbook, it might give you an equation, but that's a peek into tomorrow. So all you need to do is evaluate, just like the homework. Okay? All right, see you tomorrow.